In this video, I will answer you question number 5 from Pearson Edexcel A-level exam for Pure Maths 4. This exam is taken in May-June session year 2024. Paper reference code is WMA 14/01. Figure 2 shows a sketch of the curve defined by the parametric equations x equals to t square plus 2t and y equals to 2 over t into 3 minus t. And value of t is from a to b, where a and b are constants. The ends of the curve lie on the line with equation y equals to 1. Find the value of a and value of b. Look at the figure. This line has equation y equals to 1. And this curve is intersecting this line at point A and B. If you replace the value of y here, we can find those values of t. By using this one, it means you are finding the values of a and b. This question is very simple. Just substitute y equals to 1 in this equation. We will find the points of intersection. For the first part, substitute y as 1 equals to 2 over t into 3 minus t. This will multiply on the left side because it is dividing here, and also expand the bracket. So it will be 3t minus t square is equals to 2. You can take these two values to the right side, so t square becomes positive. This 3t is minus 3t and plus 2 is already there, so you can write here. Now this is quadratic in terms of t, and we could find the two values for t from here. Factorize this equation. There is very simple rule. Just find the factors are two numbers that if you multiply you should get 2, and if you add or subtract you should get the middle number. So here we will get these two numbers here. So first number will be minus 1 and the other will be minus 2. Minus 1 multiply minus 2 is giving you plus 2, and if you solve these two you are getting the middle number. T minus 1 is equals to 0 and t minus 2 is equals to 0. From here you are getting value of t as 1 and the other value of t will be 2. Look at the figure. On the left side value will be 1 and on the right side value will be 2 for sure. Therefore, value of a will be equals to 1 and value of b is equals to 2. So this is the answer for the first part. Hopefully you understand it. This value is 1 and this value is 2. The next part, the region R shown shaded in figure 2 is bounded by the curve and the line with equation y equals to 1. Show that the area of region R is given by m minus k integral from a to b t plus 1 over t into 3 minus t dt, where m and k are constants to be found. Area of region R, you need to find that area. Look at the figure. We need to find this shaded part, shaded region. Look here look at this figure. The area below this line, the line that has equation y equals to 1, you could find that area. And if you subtract the area below the curve, this one, the shaded below this curve area is this one. Area below the line minus area below the curve will give you the area of the shaded region. Area below the line, this line, minus area below the curve will give you the area for the shaded region. Got it? So this will be the formula in this question to find the area for the shaded region R. Let me write that formula here, then we will discuss the next point. For the second part, we want to find area of R, the shaded region R. That will be equals to area below the line, area under the line minus area under the curve. This formula we will use in this question. First of all, let me tell you how to find area by using integration. There is a formula for regular Cartesian equation, like if y equals to f of x. If there are two variables given, that are called Cartesian equations. If the variables are given x and y only, that are Cartesian equations. If there are three variables given, like in this question, we have x, we have y, and the third variable is t, these type of equations are called parametric equations. For Cartesian equations, finding the area under the curve is this formula. This formula is for regular Cartesian equation, y dx. Here we have values for x1 and x2, like 2 points are given in for x values. Got it? And this is formula for regular Cartesian equation. But for parametric equations, like these parametric equations, we will use this formula, y dx by dt into dt. So this is the formula for parametric equations, finding the area under the curve. We will use this formula in this case, and here values, t values are given for the limit t1 and t2. You understand it? Hopefully you understand, but you should memorize this formula for parametric equations, how to find the area of under the curve by if the parametric equations are given. So we are using this formula. Here we have y is given. There are two y's, one value for the line and the other value for y for the curve. And second thing, you should get the derivative of x with respect to t. So you should get here dx by dt as well. Dx by dt could be found from here, dx by dt, that will be equals to 2t plus 2. So dx by dt could be found from here. Got it? Dx by dt is this value, 2t plus 2. And we have the values for t values are also given from 1 to 2. So by using this formula, we will find the area for the shaded region. By using this formula for area under the curve for parametric equations, here are t1 and t2, y dx by dt into dt. We will apply this formula for area under the line. For the line, area will be equals to, because it is from 1 to 2, we will take the limit from 1 to 2, and here y is 1, and dx by dt we already got it, that is, let me show you this one again, that is 2t plus 2 into 2t plus 2. This is the area under the line from 1 to 2. This is the equation of the line, y equals to 1 for this one, and this one is dx by dt, and here we will write dt. Then minus area under the curve. For curve, the equation is given there from 1 to 2. Value of y is given there. That is 2 over t minus 3 minus, that is 2 over t into 3 minus t. We will use this value for y to find the area under the curve. 2 over t into 3 minus t. And dx by dt we already found it. That is 2t plus 2 and dt. Now the simple thing here, we will just integrate this function. Better you keep 2 outside of the integral common, so it will be from 1 to 2, and we can write as t plus 1 dt, and then minus from here 1 to 2, 2 is common, that common will multiply by 2, you get here 4, and we will get the result as t plus 1 over t into 3 minus t and dt. Integrate this function, we get the result as 2 into, here it will be t square over 2, derivative integration for t will be t square over 2, and integration for 1 will be t only. Then limit is given here, that is 2, lower limit is 1 and upper limit is 2. And we will keep the other function as is, 4 is outside, and here we can write as limit 1 to 2, and here will be t plus 1 over t into 3 minus t dt. Let's go back to the question. Actually we got this result, t plus 1 t into 3 minus t dt, and k, we found the value of k, that is 4 for sure. This, we will keep this function as is, and we will simplify this one. In the next step, we just plug in the upper limit here, solve this function, replace t with 2, and here 2, you get the answer for this one. In the bracket, 2 square is 4, 4 divided by 2 is 2, and 2 plus 2 is 4. You get answer 4 once you plug in 2. Then minus of formula, we plug the value 1 here, it will be 1 over 2 plus 1, that will be equals to 3 by 2. And here, keep this function as is, because we got the same result, what is required, t plus 1 and over t into 3 minus t dt. If you solve this one, 8 minus 3 is 5 over 2. 2, that 2 will be cancelled out. If you simplify by using calculator even, that will give you an answer 5. So area of R is 5 minus 4, integral from 1 to 2, and here t plus 1 over t into 3 minus t dt, where you can find you can mention the values of here. If you compare this one with that, value of m is 5 and value of k is 4, where m equals to 5 and k equals to 4. So this is the answer for the second part. Now for the next part, let's move to the next part. Write this function in the partial fraction. First of all, use algebraic integration to find the exact area of R, giving your answer in simplest form. First of all, we have to apply the partial fraction for this function in the next part. For C, by using partial fraction, we can write this function as t plus 1 over t into 3 minus t. You know, we have linear factors here in the denominator, so you can write as a over t plus b over the second factor, that is 3 minus t. Here you can close the bracket. Now in the next step of partial fraction, we always multiply by this denominator. Multiply by this denominator, t into 3 minus t. Here we get the result as t plus 1 equals, when you multiply this value by this function, t will cancel out and a will left with 3 minus t. And once you multiply this value with the other factor here, b over 3 minus t, 3 minus t is cancelled out and b left with t only. Now you can expand this one or you can substitute the values. I think the easiest way, substitute this function equals to 0 here, like t equals to 0, for sure you will get the value of a. This is the rule, by the way. Substitute t equals to 0. On the left side it will be 1, and this one will be 3a, and the other one will be 0, because you are substituting t equals to 0. Implies that value of a is equals to 1 over 3. Now substitute this value equals to 0, 3 minus t equals to 0, you will get the value of t from here, that is equals to 3. Substitute t equals to 3 in this equation, we get on the left side 4, because 3 plus 1 is 4, and you are substituting 3 minus t equals to 0 here, so first value will be 0 and second value will be 3b, and answer for b will be equals to 4 over 3. We got the values of a and b. Substitute these two values in above equation. I already wrote this equation here, so I will substitute these values here. So answer will be 1 over 3 divided by t. So that 3 will divide this. Actually it is like that, 1 over 3 over t. It means you can write as 1 over 3 divided by t. So this 3 will multiply by t. You can write directly even here, 1 over 3t, plus the same way the second value will be 4 over 3, that 3 will multiply here, 4 over 3 into 3 minus t. So this is the required partial fraction for this part. First part is done for the last part. Second part of this one, we want the exact area of R. Exact area of R. It means you need to find integration for this function. To integrate that function, we can write as 4 integration from 1 to 2, and here is t plus 1 over t into 3 minus t dt is equals to, you can substitute the value of this function from the previous part as 4 is outside, and integral from 1 to 2, and apply. Instead of writing this one, you can write this answer here, 1 over 3t plus 4 over 3 into 3 minus t dt. We can apply the integral inside, so 4 and 3 is outside of the integral, 4 over 3 is outside of the integral, and limit is from 1 to 2, and here you can write as 1 over t dt. Then plus 4 multiply 4 is 16, 16 over 3 keep outside of the integral, 1 over 2 here, and here you can write as 1 over 3 minus t dt. 3 minus t dt. 3 minus t dt is equals to 1 over 3 divided by t. 1 over 3 is outside of the integral, 4 over 3 is outside of the integral, and limit is from 1 to 2, and here you can write as 1 over 3 minus t dt. There is a formula, very famous formula for finding the integration of such kind of function. You have to memorize this formula, by the way. Like here is the derivative in the numerator and denominator is the function, and derivative is given in the numerator. Then we take the log of the denominator. This is the formula, plus c. But when definite integral is there, we are not adding c here. This is the function in terms of t, and this one is the derivative of this function. So it means we can apply this rule. We will take the log of the denominator here. But the problem is here. What is the function here? This is 3 minus t. But we want derivative here minus. Derivative of this function. This function is given in t. Derivative should be here. Derivative of this function should be there. But here derivative of 3 minus t is minus 1. But here is plus 1. So you can make here minus, but keep minus outside. It will be balanced then. This will be 4 over 3, and here this is log t, and this is minus 16 over 3, and this is log of 3 minus t. So you can apply this limit to the whole answer. Apply the upper limit there, so you get the answer as 4 over 3 log 2 minus 16 over 3. Once you put here 3 minus 2 is log 1. Upper limit is applied. Now we will apply the lower limit, 1. So 4 over 3 log 1 minus 16 over 3 log 3 minus 1 is 2. So it is log 2. We know that log 1 is 0. Log 1 is 0. So this will be 0 and this one is 0 as well. So it left with only 4 over 3 log 2 and minus, this is 0, this minus and that minus makes it plus, so it will be 16 over 3 log 2. By using law of logarithm, this multiple becomes a power. This multiple becomes the power of this one. So you can write as log 2 power 4 over 3 plus log 2 power 16 over 3. Because 2 log, there is another rule of logarithm, log x plus log y, that is equals to log of the product of these two numbers. This is the formula. There is plus sign, so you can multiply the numbers as per this rule of logarithm. So answer will be log 2 power 4 over 3 will multiply by 2 power 16 over 3. And answer of this one will be log of 2 power, because the two bases are same, you can add the power, so it will be 20 over 3. This is the answer for this part. Okay, we got the answer for that. Substitute this answer to find the exact area of R. Therefore, area of R, the area of R will be equals to, there is 5 already there, minus log of 2 power 20 over 3. Even though you can simplify this one, if you want to bring it here, you can take it there, no problem. Both answers are acceptable. 20 over 3 log 2. So this is the answer for the last part of this question. Question number 5 is done. If you have any question, please write in the comment box. Thank you.